In this tutorial, let's create some procedural screws. So this is just the example that I did is with the one setup, how many different types of screws that we create. So at the end of the tutorial, you should get an easy sub network to work with, and you can create any kind of screws that you want. So let's get into it. Let's start with the drywall screw. So first of all, let's create the base for our drywall screw. So let's start with tube. Let's put it somewhere where we can see it, and we probably want it a little bit longer. So since they they come in many sizes, let's try to create it procedurally so we can always change this length of our screws. So something like this, and for thickness maybe something like this. And for rows, so first thing we want to measure, so we see that this kind of tapering at the end of it. So we want some resolution so we can taper these very last edges. So maybe something like this. Now let's match size on it. So what I did is basically took the match size node and put it on my top of the polygon tool shelf. Like that, and let's now put in a taper. In our taper node, you will notice it's basically a bend node. It just automatically selected taper option. So just press B and make sure that we are capturing the y-axis. Either direction can work. So either one, and you can change the direction of it with M. So either minus -1 or the 1. So I'm going to go with 1 like that. And first thing we have to do is make sure that our tube length actually follows, our capture length actually follows our length of the tube. So go back to the tube and copy the height of it as a relative reference. Copy it and paste inside capture length. So this ensures that whenever we change our height of our tube, our bend is actually going to follow as our capture length is actually going to follow. So, and now what I'm going to do is basically use the ramp in taper, enable ramp like that. And now you can see by moving this one, you can see you can change it and you can add points. I want to add 2 more points and move them at the very end of it. So first of all, let's move this one to the end. So this basically says taper the end of it to the end. Let's move this one in here and let's move this one in here. Let's create kind of like a little bit easier inside. Something like maybe this. And let's capture more of it like that. So something like this maybe for our screw. See that maybe our screw should be a little bit for the height of it. Let's make it a little bit bigger height. You see our bend is still working as with this, basically this as our relative of all of the objects. Something maybe like this. So this is going to work out I think nicely. So, and always of course you can always go and change it as you please, but this I think is going to work out nicely. Now let's work on the threading for this screw. So put down a lab spiral node, and first thing first, we want to make sure that it follows this object. So for the height of it, let's go to the tube and copy the height and paste it in a height like that. And now let's go to the actual, and we want to make sure that the radius is also the same. So in here, the radius scale, copy it and paste it inside the radius like that. So now our screw is following our tube, but of course we have a little bit more to do. So first of all, let's make sure that our thread is not at the very tip of both of the ends of it. So since we want to basically scale in all of them uniformly from both sides, what we can do is actually put down a transform node. In transform, you can see that right now it's going to, let's say if our transform pivots here, we are basically tapering inward. So for the visualization, actually take these and let's merge them together like that. So you see it's not very useful for us. We basically want to make sure that our pivot is always at the center of this curve in the y-axis, and then we can scale them inwards from both sides uniformly. So let's put it to 0. Let's go to the pivot transform, and in the pivot transform you can see that there's an option for the pivot translate. All we have to do is put down a simple expression, put down a centroid. So centroid is basically this center of the bounding box of this object, put down 0 since this is the object we want, and you can see in the help we can basically reference the d dy, so there's going to be the y like that, and that's it. So this ensures that our pivot is always at the center of, well, at least at the y-axis. So let's say our tube is 10, our transform, you can see our transform is always at the 5, like that. So this is the procedural way for us to do it, so we don't have to manually always change the pivot location. And now, once we have set it up, we can always go back to the transform, and we can scale them in uniformly on both sides, like that. So this is how we are setting up this squishing of this, and of course we can go back to the spiral, make more loops, like that. It's all procedural, so let's make our tube, our screw a little bit longer, like that. Now that we have this setup, we probably want to start kind of creating geometry around this threading. So first of all, let's put down a sweep node. And in sweep node, let's put down the surface shape around tube as for the second one. And let's put it to the 3 columns, like that. Let's take a look at the result. You can see it's not the greatest one. So we want to make sure that this threading is actually, that the one of the sides is always at the edges of the screw. So what we can do is actually we have to create the up vector. So let's go to the sweep and let's put down a point. So it's just a point expression. In point expression, let's put down a custom name for it. Let's call it up. Let's delete this and let's say value. And this is going to enable the constant value. And since we want to make sure that it's always on up, we want to y put it 1, like that. You see, and now we basically have a constant rate of our triangular shape. It's always going to be inwards. Basically not going to, by default, it's basically going to also rotate around as we sweep it around the object. But with this being the constant value of 1, so if you go to the attribute with the point as a point attribute, you can see up is always 1. It's going to make sure it does not actually rotate around it when we sweep it around the curve. So that's that. Let's take a look at the result. So first of all, let's actually create the big radius. Obviously, we have one more thing to take care of, which is the ends of it. So in our pictures, you can see that it's basically kind of a tapers off, kind of a inwards inside the actually screw body. So let's create this kind of effect. And if you want to know more about these kind of expressions of the up, let's go to the copy and instancing point attributes. You can see this is basically one of the predefined attributes that some of the nodes are going to look for and going to basically affect the copying of any shape that we create. So you can see the in up, it's basically up vector of the copy, and that's it, and it's a vector. So these are kind of a place to look for if you want to know more about all of these predefined attributes and what they do and how can we change them and all of that. So that's kind of a side note. Now let's have more control over this shape that we are sweeping. So what I actually want to do is put down a circle node. So let's go to it. So it's going to be at the center. So let's make it 3 divisions. And what I actually want to do is let's rotate it 30 degrees so that we can easily move this. And let's actually just take this point and let's move it upwards. Maybe like turn on green snapping, maybe something like this. And now connect it to the sweep, and in surface shape, second input. And in second input, let's go to the rotation. Let's rotate it more. Maybe something like this. Let's go back to our edit and let's taper it maybe inwards. Something like this. Let's go back and let's rotate it. So, oh, there it is. So we have more of a geometry in there. So you can just go back to the edit and let's turn off the snapping, and we can control the shape that we are actually sweeping, like that. So because if we would use a circle, it would be kind of stuck with the default shape of it. So maybe something like this for now. Now what we need to do is do our tapering at the bottom and the top of it. Well, actually only at the bottom of it. So in the pictures you can see that tapering is basically right at the, you can say that even at the end of it. So let's start by putting down a linear taper after we have swept the geometry. So first of all, let's change our axis to Y. And first thing we want to do is change our capture length to be a dynamic. So first of all, for the length of it, we can't really now use our sweeps as a reference, because now we have actual geometry, and actual geometry is going to be taller than actually the sweep, the points. So what we can do is actually use the bounding box for the capture length. So start writing bounding box, and indeed, so 0, so we want the y, so this is going to be the underscore y size, and that's it. So now we have actually let's take a look at the capture length. You can see it's going to work, but one thing you have to note that, let's say our height is going to be 5. Let's go back to the taper. You can see our taper now is off, because our capture length only goes on top of it. So basically it goes in the on y direction, or on on y, either on to the top or the bottom. So now let's make our life a little bit easier, and let's put on a match size node after we have swept our geometry. And in here, just put down transform for our screw base, like that. So this is going to ensure that once we are starting the taper, we don't have to manually adjust the tapering area. We can just reference one thing and that's it. So let's go back to the merge, and let's put down linear taper. So let's cycle between it. And so for this capture area, obviously we want for this always to be dynamic, and we want to follow the length of this object. So we can't really now reference this sweep anymore, because well we can't this curve, because obviously this curve is not as high as our swept geometry. So all we have to do is just reference our bounding box for this geometry, and all we have to do is for the capture length put down the bounding box 0, and so it's going to be the underscore y size, and that's it. Now our capture length, and now we don't have to worry about both directions, because our capture length is always going to just go up since we have our match size. Let's say we go back to tube and change the height of it. Let's go back to linear taper. You can see it works perfectly. But one thing is to note that for our linear taper, we actually want to just taper the end of it. So what we can do is we can start dividing this capture length. So now it's all of the geometry. Let's say we want to only capture last maybe, I don't know, maybe 10%. Well, we can just multiply it by 0.1, like that. So you can see now we're basically only last 10% we are tapering. And for the taper, so what we're going to do is actually, let's reverse it. Just press M, and now we have reversing on other side. So let's go to the merge and take a look at the result. So first of all, let's go to taper. So one thing we can do is just squish it all the way to the end of it, like that. So you can see that maybe we are getting maybe too many artifacts in here. So what we can do is just go and change the transform for our screw itself, like that. Let's change the screw offset, like that. Let's go back to our taper back. Let's make sure that it's completely covered inside here. Let's say now we want to bring back some of these, and that's where this comes in, this squish handle. You see, now we can offset it. So you see that we can now basically tapering only the very end of it, and up here we can kind of bring back the the actual screw detail, like that. And what's great about this setup, it's completely non-destructive. So let's say I want more spirals, I just go and make them more or less. I don't like the shape, I go back to here and just go and scale them inwards or something like this, more sharper, like that. So what else I can change? Well, I can change the height of my screw. You can see that it's going to follow, and also our tapering works. And of course, if I, let's say, go back to the taper, let's go back to our taper. You can see it still works, and if we want to change it, we can definitely go and taper it even more or less, like that. So this is completely non-destructive way we can create base of our actual screw. Let's make it something like this. And for the rest of the screw, let's create that one also. So for the rest of the screw, I actually want to do something a little bit maybe different. So let's go to the transform and let's go to very top of it. So what's good about these two primitive is that, let's say we go here and let's turn on our primitive numbering. You can see we can go back to our screw and change the columns and the rows. We can change the amount of polygons we have, and this top is going to be 0. So we can actually use this as an advantage for us. Just go to here to transform, select this polygon. What we want to do is actually want to extract it. So what we have created basically a new geometry node. Let's turn off this one. That it basically has a reference to this object, to the group 0. That's always going to be here. So we're gonna do our modeling for our screw head in a totally different geometry node, and then we're just gonna merge them together, and that's basically gives us opportunity to do whatever we want in here. We can create different screw heads and then just dynamically change them and all of that. So I think this is going to be a better approach for us. So first of all, so that we have not the geometry just hanging in the middle of nowhere, let's just put down a match side node. So something like this. So it's actually at the 0 for us, so that we know where to look for it. So now what I want to do is actually start extruding it. And of course we can always go back and change these settings. So let's just extrude maybe something like this. For the inset, something like this. So like that. Now let's create also the front and back boundary groups. And what's great about this, let's say I want to now change it. I just go to the, let's say I want to bevel this group that we just created. Just turn on this display groups and attribute list, and you know that we want to front seam to bevel. So just select on this front seam and then press the shortcut key that you have for the bevel, like that. You can see it's going to put down the bevel and it's automatically going to group as a extrude front seam. So this is the one thing that you don't have to just put down the bevel. Let's say previously I would be doing this. I would select this edge, so I would have this node. I would be just select these and then just bevel it. So you can see it's going to be as a edge selection. Then I would have to go here and then delete it and then just select it. So with this selection as on the viewport, just select it and it's going to automatically fill our group like that. And for the rest of it, I probably want to boolean out the shape of the screw head. So let's put it in a box. So for the scale of it, doesn't really matter now. Let's just duplicate it. Let's rotate it. Let's now merge them together. And let's also make sure that both of these follows one another. So we know that we are changing the z-axis. So just copy the z-axis as a reference and paste inside in the second box like that. Now when we change one, it's going to change also the second one. After that, after the merge, what we can do, actually let's combine these so we can bevel it nicely. So put down a boolean, connect them, and let's say union like that. And now we have our screw head. Let's just select all of these edges and let's just bevel them, something like this. And now let's put down another boolean. Let's start booleaning it out of this shape. So you can see that we do not have a completely closed out geometry, but for boolean it actually is still going to work for us. So now let's work on our scale. So for the uniform scale, I'm gonna just put down a transform after this one, so we do not have to mess around with everything else. So just go here and start scaling it inwards, like that. So something like this. Now that we have our screw head, the first thing you have to do is make sure that once we go outside, we want to move it back to the top of the screw. So what we can do is actually, after we have done everything, put down a match size node. And the position that I want to do is we carefully connect it to the second input. So go up, and take this object merge and just connect it inside here. And that's it. Just make sure that after you have connected it, make sure that it's on Y, it's in. So it's our object is on top of the plane that we just extracted. So that's it. Make sure that you name them something that you will notice what's inside it. So what's good about this setup? So let's go back to our screw base. Make sure we see all of the objects. And so let's go back to our screw dimensions. Let's say we want to place dimensions for the columns. You can see our columns are still basically following with the actual geometry. Another thing that we need to take care of, let's say now I want to merge these objects together, but before that we actually want to make sure that for our main shape of the screw we don't have any, we delete this cap. So since we are referencing for our object merge in our screw head modeling transform 2, after transform 2 what we can do is basically just go here and delete it. So basically we are deleting once we have referenced it, we are deleting it, and once we're gonna merge it together, it's going to basically not gonna affect our geometry reference from this one, since we are referenced in transform 2 and in transform 2 we still have this polygon 0. Now let's go back to our screw base and let's actually merge these together. So now our geometry is going to merge. Let's say this is going to be our base. Let's put down object merge. And object merge, you want to reference our extract. So what we can do is actually dot slash, and select extract screw head like that, and that's it. So now we have basically imported this object in this network, and what we can do is just take these and just merge them together like that. With this method, it's very easy for us to change the screw head. So let's say what I did is basically create 3 types of screw heads. So let's put this also inside the network. Now we can name them. Basically have 3 different screw heads that goes into switch and then goes into match size. Now let's say I have different screw head. I basically model my screw head inside here, and here I can basically switch between them and choose whatever I want as a screw head. So that's why we did it that, so that we can always go and change it. So, but now we have to clean up our geometry. Now let's clean up our geometry. First of all, what we can do is instead of using merge, let's use a boolean. So in boolean, let's delete this merge and let's connect these screw base and the threads. Let's connect them and let's make them to the union. So you can see that even though we have opened geometry up here because we blasted top of it, we're still getting our boolean in here. So even if we would disable it, basically would be the same thing. So and now you will notice that we're getting this ugly artifacting. So let's put down normal nodes before we actually use a boolean, something like that. So now we have cleaned up with the minimal artifacting. You will notice that obviously it depends on how much you want to now clean up your geometry. First of all, you can see that our geometry in here is very stretched out. So if you, let's say, you want for nice close-up, maybe you would want to more divisions inside this one. So what we can do is actually go to the circle that we just go back to the circle, and so for the circle what we can do is resample it, and then resample, let's just go inside so much so we get, so maybe this is a little too much, just move it around so we get maybe, let's go back and this edit, we want to actually edit before we resample it like that. So this is going to work out like that, because we are basically resampling and then editing it, but of course we want to edit before we resample it. You can see it's resampled curve, we can already get a lot much smoother results. So for the base of the screw, we can just maybe not completely fuse this very backward. So let's go back to our taper. And you can do is actually expand this profile. So just press on maximize ramp, and you can see that we can actually change it. So let's not completely fuse them together. Maybe something like this. So this is going to give us maybe better results like that. And if you have a modular toolkit, you can use also sort boolean. Let's take a look at them. You can see that it's really going to create these kind of a soft transitions between the two objects like that. So if you're really looking for the close-ups for this object, that is definitely one of the options. And what's great about this, that since it's actually going to subdivide only the actual spirals of it. So once we have soft boolean it, we can actually totally just merge it together with the screw head. You can see it's still going to connect with it, so that's another option you can go with. That's it for this video. I hope you learned something. I think I have talked everything that I wanted to talk about this one. Obviously you can just reiterate it and make it even better, but for the screws, for the procedural approach, that's it for me, and see you next time.